Pre-statistics. Using the quadratic formula to solve quadratic equations. Part 2. Lesson objective. Solve quadratic equations by using the quadratic formula. We'll begin with an example. Example 3. 1/2 x squared minus 5/4 x equals 3/2. Solution. We begin with our original equation. To eliminate the fractions, I'm going to multiply by the least common multiple of the denominators, 2, 4, and 2. So every term gets multiplied by 4. 4 times 1/2 is 2. 4 times 5/4 is 5. And 4 times 3/2 is 12/2, or 6. So we have the equivalent equation 2x squared minus 5x equals 6. The next step, we subtract 6 to both sides, so the quadratic equation is in standard form. A is equal to 2, B is equal to -5, and C is equal to -6. So using the quadratic formula, I put -5 in for B, I put 2 in for A, here and here, and C is a -6, it goes here. Next, we evaluate this expression. 5 squared is 25, minus 4 times 2 times -6, which gives us a -48. A -5 is positive, and 2 times 2 is 4. Next step, 25 minus a -48 is the same thing as 25 plus 48. 25 plus 48 gives us 73. 73 is not a perfect square, but it does not have any perfect square factors. So this is our exact solutions. 5 plus the square root of 73 divided by 4, and 5 minus the square root of 73 divided by 4. To verify these solutions using the graphing calculator, we type in the left-hand side of the equal sign and y1. Use our table feature, type in our exact answer, 5 minus the square root of 73 divided by 4, and the y is 1.5. And that is exactly what the right-hand side is. 3 divided by 2 is 1.5. To check the other solution, 5 plus the square root of 73 all divided by 4. Hit enter and you should get 1.5 again. So we have verified the solutions to this equation. Example 4. Solve 2x squared plus 2x equals -6x plus 10. Solution. Our first step is to move all the terms over, so the quadratic equation is equal to 0. So we add 6x to both sides, combine like terms, and we get 2x squared plus 8x equals 10. Then we subtract 10 to both sides, and the equation is equal to 0. So in this case, A is 2, B is 8, and C is a -10. So 8 goes here and here, 2 goes here and here, and -10 goes here. 8 squared is 64, minus 4 times 2 is 8. 8 times -10 is a -80. 2 times 2 is 4, and a negative times 8 is a -8. Next, we want to combine like terms here. So 64 minus -80 is the same thing as 64 plus 80, which gives us 144. So we have -8 plus or minus the square root of 144 over 4. 144 is a perfect square. It's 12. So we have x equals -8 plus or minus 12 divided by 4. This is two numbers, so we'll split them. The first one will be -8 plus 12 divided by 4. -8 plus 12 is a +4, divided by 4 is 1. So x equals 1. The other solution is -8 minus 12, which is -20, divided by 4 gives me negative 5. So x equals 1 and x equals negative 5. To verify this using the graphing calculator, in y1 we put the left hand side of the equal sign, y2 we put in the other. So y1 will be a quadratic, a parabola. y2 is linear, it'll be a straight line. Here's the graph. We see one point of intersection, but it's hard to see. If we use the table feature, we'll see when x is 1, y1 and y2 are the same value. And when x is a negative 5, y1 and y2 are the same value. If we want to look at this graphically, pressing window, we will put the x-min and x-max negative 10 to 5 because we know the points of intersection are at negative 5 and positive 1. So this gives us room on the x-axis to see both x-coordinates. For the y-min and y-max, the y-min will be negative 5, so I can see the x-axis, and the x-max will be 50 because from the table I saw a value of 40 for the y, and then we'll count by 5s on the y. Hit graph, and we see here's a point of intersection, here's a point of intersection. We can have the calculator compute these points of intersection by hitting second and trace, which is calculate, go to intersect, select the two graphs, and we see when x is 5, y is 40, and the second intersection point when x is 1, y is 4. Example 5. Solve 2.3x times the binomial 1.4x minus 5.3, and that equals 6.9x minus 7.2. Solution: we need to write this in standard form. So the first step is to use the distributive property. We want to distribute 2.3x to both terms. Next, we want to subtract 6.9x to both sides, and then we want to add 7.2. We now have the equation in standard form. It's equal to 0. So A is 3.22, B is a negative 19.09, and C is 7.2. Substituting these values in the quadratic formula, we have negative b plus or minus b squared minus 4 times a times c divided by 2a. Squaring first, then multiplying, then subtracting, we end up with this value. A negative becomes positive, and 2 times 3.22 is 6.44. Next, we want to evaluate this. So to 2 decimal places, this is 16.48. So we have two values, 19.09 plus or minus 16.48, all divided by 6.44. And we get a value of x is 0.41 approximately, and x is approximately equal to 5.52. To verify this, we type in the left hand side in y1, the right hand side in y2, and again using the intersection feature we can verify the solutions. Thanks for watching.